The mystery of weightlessness. Is there no gravity in space? Have you ever looked up at astronauts floating in space and wondered, is there no gravity up there? It's a common question and the answer might surprise you. We see astronauts floating weightlessly, seemingly unaffected by gravity. This leads many to believe that space is a place without gravity. However, that's not quite right. Gravity is everywhere in space, even though it seems absent. The feeling of weightlessness astronauts experience is not due to a lack of gravity, but rather a unique situation they're in. Let's unravel this cosmic mystery. Gravity, the force that holds us together. To understand why astronauts float in space, we need to delve into the fascinating world of gravity. When we see astronauts floating inside their spacecraft or during a spacewalk, it might seem like there's no gravity at all. However, that's not entirely true. They are actually in a state of continuous free fall towards Earth, but because they are moving forward at such a high speed, they keep missing it. This creates the sensation of weightlessness, or what we call microgravity. To truly grasp this concept, we need to understand the fundamentals of gravity. Gravity is not just a force that pulls objects downwards. It is a universal force that acts between all masses. It is the reason why planets orbit stars, why moons orbit planets, and why we stay firmly on the ground. Simply put, gravity is a force of attraction between any two objects with mass. This force is what makes an apple fall from a tree, and what keeps the moon in orbit around the Earth. The strength of this force depends on the masses of the objects and the distance between them. The more massive an object, the stronger its gravitational pull. For instance, Jupiter, being the largest planet in our solar system, has a much stronger gravitational force than Earth. This is why it can hold on to so many moons and even influence the orbits of other objects in the solar system. Earth, being a massive planet, exerts a strong gravitational force on us, keeping us grounded. This force is what gives us our sense of weight and keeps everything from drifting off into space. This force is what makes objects fall to the ground and keeps us from floating away. When you drop a ball, it falls because Earth's gravity is pulling it towards the center of the planet. This same force acts on every object, including us. We feel the Earth's gravity as our weight. When you step on a scale, it measures the force of gravity pulling you down. This is why your weight can change if you travel to a place with a different gravitational pull, like the moon, where gravity is much weaker. Gravity is a fundamental force in the universe, responsible for holding planets in orbit, stars in galaxies, and galaxies within clusters. Without gravity, the universe as we know it would not exist. It is the glue that holds everything together, from the smallest particles to the largest cosmic structures. Gravity's long reach, from Earth to orbit and beyond. Here's the fascinating part: gravity's reach extends far beyond Earth's surface. It's not just a force that keeps us grounded, it extends into the vast expanse of space, holding celestial bodies in their orbits and influencing the movement of planets, moons, and even comets. It weakens with distance, but it never truly disappears. The gravitational force diminishes as you move further away from Earth, but it continues to exert its influence no matter how far you go. This is why planets remain in their orbits around the Sun and why moons orbit planets. Even when astronauts are orbiting Earth hundreds of miles above us, they are still under the influence of Earth's gravity. This gravitational pull is what keeps the International Space Station in orbit, allowing astronauts to conduct experiments and live in space for extended periods. In fact, the gravitational pull they experience is only slightly weaker than what we feel on Earth's surface. At an altitude of about 250 miles, the force of gravity is still about 90% as strong as it is on the ground. This means that while astronauts feel weightless, they are still very much under the influence of Earth's gravity. So why don't they fall back down? The sensation of weightlessness is due to the fact that they are in a state of continuous free fall towards Earth. However, they never actually reach the surface because they are moving forward at such a high speed. The answer lies in their incredible speed. The International Space Station, for example, travels at a velocity that allows it to fall towards Earth, but also move forward fast enough to keep missing it. This delicate balance between gravity and speed is what keeps the ISS in orbit. Astronauts on board the International Space Station, ISS for instance, are traveling at a staggering 17,500 miles per hour. This speed ensures that they remain in orbit, experiencing the unique conditions of microgravity, which allows for groundbreaking scientific research and a better understanding of life in space. Freefall, the feeling of weightlessness. This incredible speed is crucial because it allows the ISS to constantly fall around Earth. The ISS orbits Earth at a speed of approximately 28,000 kilometers per hour, or about 17,500 miles per hour. This speed is not arbitrary. It is precisely calculated to ensure that the station remains in a stable orbit. If the ISS were to travel any slower, it would not be able to counteract the gravitational pull of Earth and would eventually fall back to the surface. Conversely, if it were to travel any faster, it would escape Earth's gravity and drift off into space. Imagine throwing a ball horizontally. The faster you throw it, the farther it travels before hitting the ground. Now, imagine throwing it so fast that it keeps falling but never actually hits the ground. This is essentially what happens with the ISS. The station is moving forward at such a high speed that as it falls towards Earth, the curvature of the planet causes the ground to drop away beneath it. This creates a continuous freefall effect. Astronauts on the ISS are essentially in a continuous state of freefall. This means that everything inside the station, including the astronauts themselves, is falling at the same rate. As a result, they experience what is known as microgravity, where the effects of gravity are much weaker than on the surface of Earth. This allows them to float around the station and perform tasks that would be impossible under normal gravitational conditions. They are constantly falling towards Earth, but moving horizontally so fast that they keep missing it. This delicate balance between the pull of gravity and the forward motion of the ISS is what keeps it in orbit. It's a fascinating dance of physics that allows astronauts to live and work in space for extended periods of time. This constant state of freefall creates the sensation of weightlessness, also known as microgravity. In this environment, astronauts can conduct experiments and perform tasks that would be difficult or impossible on Earth. For example, they can study the effects of long-term exposure to microgravity on the human body, grow plants in space, and even observe how fluids behave without the influence of gravity. It's like being on a roller coaster when you go over a steep drop and feel that momentary lightness in your stomach. That brief sensation of weightlessness is similar to what astronauts experience continuously while in orbit. However, unlike a roller coaster ride that lasts only a few seconds, astronauts feel this way for the entire duration of their mission, which can last for months. That's essentially what astronauts experience all the time in orbit. This unique environment allows them to conduct scientific research that can lead to new discoveries and advancements in various fields, from medicine to materials science. The knowledge gained from these experiments not only helps us understand more about living and working in space, but also has practical applications here on Earth. They are falling towards Earth, but their horizontal speed prevents them from crashing. This delicate balance is what makes life on the ISS possible and allows astronauts to experience the incredible sensation of weightlessness. It's a testament to human ingenuity and the wonders of physics that we can create such an environment and use it to push the boundaries of what we know and can achieve. Section 5. The International Space Station, a case study in microgravity. The International Space Station serves as a perfect example of this phenomenon. Orbiting Earth at an altitude of about 250 miles, the ISS is constantly falling towards our planet, but simultaneously moving forward at a rapid pace. This delicate balance between gravity and speed keeps the ISS in a stable orbit, allowing astronauts to live and work in a seemingly weightless environment. Section 6. Orbits. A delicate balance of speed and gravity. The speed required to maintain an orbit depends on the altitude. The higher the orbit, the slower the speed needed to counteract gravity's pull. For instance, the Moon, orbiting Earth at a much greater distance than the ISS, travels at a slower speed of about 2,300 miles per hour. This delicate interplay of gravity and speed is fundamental to understanding the motion of celestial objects. It governs the orbits of planets around stars, moons around planets, and even stars within galaxies. Section 7. Gravity's cosmic dance shaping the universe. Gravity's influence extends far beyond our solar system. It is the architect of the universe, shaping galaxies, clusters of galaxies, and the cosmic web itself. From the smallest atoms to the largest superclusters, gravity plays a pivotal role in the grand cosmic dance. It draws matter together, igniting stars and forming planets. It holds galaxies together, guiding their motion and influencing their evolution. Gravity's pervasive influence shapes the universe we observe today. Section 8. the truth about gravity in space. So the next time you see astronauts gracefully floating in space, remember that they are not experiencing an absence of gravity. They are in a continuous freefall, perpetually falling towards Earth, but moving horizontally fast enough to stay in orbit. Gravity is not absent in space. It's everywhere. It's the force that holds the universe together, from the smallest particles to the largest cosmic structures. Section 9. Conclusion: gravity's ever-present embrace. In conclusion, the feeling of weightlessness in space is not due to a lack of gravity, but rather a constant state of free fall. Gravity is a fundamental force that permeates the cosmos, shaping the universe we inhabit. As we continue exploring the vast expanse of space, we must remember that gravity is an ever-present companion, guiding our journey and shaping our understanding of the cosmos.